This video will be the second part to section 2.3 on functions. So what we want to do is look at these three different equations, and we want to decide really what we're going to look at. We're not going to worry about if it defines a function. We're going to just look at the domain. Alright, so when you look at the first equation, this is a linear equation. And remember, we talked about these linear equations in part 1 when we were looking at the graph of that linear equation. And I told you to make a note down there somewhere on your paper about any time that it's a linear equation, the domain and range will always be the same thing. And so remember, we said anytime we have a linear equation, the domain and the range are always going to be negative infinity to positive infinity for both of them. Alright? And so anytime you see it, even on the test, if it asks for a domain of a linear function, this is always the answer. Alright, the next one is a square root equation, or a square root function, however you want to call it. And remember, there are restrictions on square roots. What can be under the square root sign? It can't be a negative number. So if we're looking for the domain of this function, remember, domain is the set of all x values. And so I can fill in all kinds of x values in here and get out a y. But what I can't fill in is some value for x that is going to make what's under here be negative. Alright, so to find out what all the possible solutions are, we take the radicand, and remember, that's whatever is under this radical sign, in this case 2x minus 1. Alright, and I'm going to set it greater than or equal to 0. Alright, because the smallest value that can be under this radical sign is 0, and then it can be anything bigger than that as long as it's not negative. So 0 in any positive numbers. So what I'm going to do is find all the possible values that are going to make 2x minus 1 be 0 or greater. Alright, I'll solve the equation by adding 1 to both sides and dividing by 2. I'm not going to write that down because we've done lots of those already. So move 1 over and divide by 2, and you'll get 1/2. And so this says that the domain can be any value that is greater than or equal to 1/2. And we could write it like this: 1/2 to positive infinity. So anything between 1/2 and infinity would be in the domain. Anytime you see this, even on the test, you're going to take what's under the radical sign, set it greater than or equal to 0, and solve for x. Then we'll write our answer in interval notation, showing all of the possible solutions. Let me rephrase that. Showing all of the values in the domain. Alright, the third equation is a rational equation. It's a fraction, the variable's down in the denominator. Alright, back when we were solving rational equations, we would get rid of the fraction, solve it, but then remember, at the end we had to check to see if our solution would make the denominator 0, because in a fraction you can never have the denominator equal to 0. Alright, so if I'm filling in values for x, values from the domain, I can fill in any value except the value that makes this denominator be a 0. So what I'm going to do is find the value that makes it 0, and then any other value is in the domain. Okay, so we're going to take the denominator, and we don't want it to be 0. Alright, so if I solve this, I find that I do not want x to be a 1, or x can't be a 1 because if I filled it in, 1 minus 1 is 0, making this undefined. Alright, so this is saying any other value besides 1 can be in the domain. Now, I would be okay on the test if you left it like that, but the proper domain would be negative infinity to 1, and we put a parenthesis around it to say don't include 1, but anything up to 1, so like 0.99999 could be in there, but not 1. And then anything greater than 1 could be in there. And then to make these two go together, we put the union symbol in there to say these are the values of the domain. Alright, so let's take a review there. We have linear, always, this is the domain. If it's a square root, we always take the radicand, set it greater than or equal to 0, and solve for x. If it's rational, we take the denominator, set it not equal to 0, and find what makes it 0. That's the only value that cannot be in the domain. Here are all the other values that can be in the domain. Anytime you have these equations, this is how you're going to find the domain. Alright, looking next. Alright, we've been talking about all these equations that say y equals y equals y equals. Alright, and the equations that are functions, we can write them using function notation. And function notation is this right here. Alright, it is read as f of x, not f, it's not f times x. Alright, it's read f of x. Alright, and that simply means I have some equation where x is the variable. And f of x and y are the same thing. The f of x is just saying that this is a function, and I'm filling in for the variable x. Alright, this is a function, I'm filling in for the variable x. You may see f of x, g of x, h of x, all kind of x's. Alright, and the f, the g, the h are really just names, and they help us identify the different equations. If all of them were f of x and I ask you to do something with f of x, then you wouldn't know which equation to use. It's kind of like you have a name, and so if I want to ask you to do something or identify you, I call you by your name. And that's what this f and g are. Alright, and then the x just says I'm going to fill into the variable that's in the function. If it happens to be f of t, that means in the equation, the variable t is used, so it may be like t squared plus 1. Alright? Remember, it's read f of x. Alright, so what we're going to do is we're going to look at these two functions, f of x, which is negative x squared plus 5x minus 3, and then the function g of x, which is 2x plus 3, and we're going to do the following things. Alright, so if I see f of 2, alright, there's a number where the variable used to be. That means everywhere there's a variable, I'm going to put the number 2. Or everywhere there's an x, I'm going to put the number 2. So I'm going to go to function f. Alright, this is function f. And in place of the x's, I'm going to put a 2. Alright, so 2 squared is 4, and then the opposite of that makes negative 4. Plus 10 minus 3. Then negative 4 and negative 3 are negative 7 plus 10 makes 3. Alright, so if I put a number in, I should get a number out. Alright, and here, f of q simply means everywhere there's an x, I'm going to put a q. So that'll give me negative q squared plus 5q minus 3. Alright, letter C is, now we're using function g, which is 2x plus 3. So everywhere there's an x, I'm going to put a plus 1. So I'll say g of a plus 1. And everywhere there's an x, I'll put a plus 1. And so here's x. So this is like 2x plus 3. Then I multiply it out. 2a plus 2 plus 3 gives me 2a plus 5. Alright, looking below. Alright, for each function, we want to find the value of the function when x is 3. So that's what this means. Find the value of f, or what's the value of the function, or what does y equal? We could think of it that way. When x is 3. Okay, so remember f of x and y are the same thing. They don't mean anything different. Alright, that's just a notation to say this is a function. Alright, so on letter A, if I want to know what is y when x is 3, I simply fill 3 in for x. Alright, so 3 times 3 is 9, minus 7 makes 2. Alright, I'm going to do the same thing for B. Alright, Alright, so looking at this is f. Alright, and so instead of giving us an equation, they gave us the set of ordered pairs. Alright, so if I look at the ordered pairs, I want to know what is y, or the value of the function, when x is 3. So I simply look at the ordered pairs and I find where x is 3 and look to its y value. So when x is 3, y is 1. If I, had wanted to know what is the value when x is negative 3, then you would say 5. Or the value when x is 0, y would be 3. So remember, these, which we did earlier, this relation is a set of ordered pairs, which are solutions to functions, or solutions to equations. So this says when x is 3 that y is 1, or when x is 3 the function has a value of 1. Alright? Alright, looking here, I want to know what is the value of the function when x is 3. So the domain are the x's. I follow the arrow to find that it is 5. Alright, for this one, the value when x is 3. Alright, I go to 3 on the x-axis, and then I go to the graph. Alright, where does the, right here, so that location is 3, 4. So when x is 3, y has a value of 4, or the function has a value of 4. Okay? Now we're going to be doing this a lot of times, especially these right here, filling in and finding the value of the function. So keep in mind, all these things are solutions to these functions. Alright, and if I took this right here, and I wrote it as an ordered pair, it would look like this, 3, 2. Alright, and then I could find, I could use these to graph the equation. Alright, let's look down here at number 8. Alright, it says assume that y is a function, f of x. We want to rewrite these equations in function notation, and then find the value of f of negative 2. And we're not going to worry about that one. Alright, so remember that f of x and y are the same thing, so to write it in function notation, I simply replace y with f of x. Alright, but before you can replace y with f of x, the y has to be all by itself. So it has to say y equals everything else. Alright, now I'm going to substitute in the value negative 2. So I'll find f of negative 2. I'll fill it in. That'll give me 4 plus 1, which is 5. And so if I wrote it as an ordered pair, that would be negative 2. 5 would be the solution. Alright, on this equation we have x minus 4y equals 5. I can't just put f of x in y's place because it doesn't say y equals. So I'm going to solve this equation for y. So I'm going to subtract x from both sides. Alright, then I'm going to divide everything by negative 4. Alright, and that'll give me y equals x over 4 minus 5/4. Now I can take and write it in interval notation. That's not what I meant. Now I can take it and write it in function notation just by replacing y with f of x. Alright, then I can fill in negative 2. So that'll be negative 2 over 4 minus 5/4 would give me negative 7/4 as my answer.